Hi, I'm Alex Williams, the New Stack. In this discussion, I talked to Ken Owens, Chief Technical Officer of Cloud Infrastructure Services at Cisco. We did the interview as part of the New Stack's ebook series on Docker and the container ecosystem. Cisco is a sponsor of the series.
What I would like to do is just really get the story about it, from the beginning, really, and looking at looking at the projects now and where you are going forward with things. And one of the things we're trying to understand, is, what are companies learning when they start these projects internally, and how is it then becoming part and parcel of what they are then sharing in the open source community. The story, starting from the beginning, I think a lot of it does, I would expect, a lot has to do with your participation, in developing this community on GitHub. In particular, I'm looking at the Cisco Cloud and Microservices Infrastructure repository. And there's a lot in here, right? I mean, this shows, the depth of your, what you're doing. It shows the number of different technologies that you're using to make this possible. It's actually really quite complete. So how did you get started? Why don't we start there?
Okay, so I think the view that I have of this is probably a little bit different than other people you talk to, primarily because I look at this from a business acceleration and how do we help businesses accomplish their objectives quicker, right? And so as I've looked around at how every company is becoming more of a software company and what Cisco has been starting to call this digital disruption, where you either have to, become a software company and disrupt your industry, or your industry will become disrupted like the Netflixes and the Amazons and the Ubers have been doing in those industries, right? And at the same time that I've been looking at this sort of macro pattern of disruption happening, I've been watching how, as you went from, IT delivering a service in 3 to 6 months to the business and the pain points that they were going through with server and network and storage, and then move into a virtualization world and never really solving all of the problems that developers had, but just basically making it easier to get infrastructure sooner. But developers still had the same problems they'd always had, because to a developer, infrastructure is not what they're trying to develop, right? It's just a means to put their services up on a location. And then as we move to move to cloud and multi-cloud scenarios, right? They still haven't solved any of the developer problems. You're just solving where you deploy and who pays for that hardware, right? You're still, you might be consuming it as a service, but from a developer standpoint, they still have the exact same problems they've always had. When you kind of look at those two areas, that's kind of where we started with our vision, right?
So the first part is really the realization you have to become a software company, or you can get disrupted, as we see with Uber and stuff. And the other consideration is kind of the way IT has delivered services. For example, in these 3 to 6 month time frames, but never really solving the problems that developers have, right? Developers were still trying to get their apps out, but the IT group was really focusing on building out the infrastructure.
Right. And when you combine those two things, you kind of have a recipe for a major issue, right? Because you can get infrastructure very quickly now, but your developers you're leaving all the heavy lifting and all the hard work now for the developers to try to figure out how to plug all of their components together, how they're going to test it, how they're going to provide assurance of their software, and how they're going to continuously integrate and deploy that software over time. So you need to be very quick and very software centric, but you've basically made it harder than ever for developers to really accomplish what they need to accomplish and maintain their code over time.
So you're saying you need to be quick, to be a software-centric company. But what's happening in the meantime, facing these issues? Can you kind of clarify that for me then?
The main issues, I can go into a little bit more detail on this too as I kind of go through the discussion. But the biggest issues have to do with project management. Like most enterprises have a way that they kind of manage their projects. And that's usually something that the developer has to then integrate with their tool sets. And in some cases, they're already integrated, but in many cases, they have to sort of integrate that tool set with their project management software. And then they have a source code repository somewhere. They have to put their source code. That source code repository is usually on an internal network, so there's no external access from that source code to any of the different QA or integration lab or production systems that they then want to connect to and push their code out to, right? So they have to figure out how to get all that connected. They're also trying to do continuous integration and deployments, and that's hard enough inside an enterprise. Now when you start adding, cloud to that, it's very difficult to kind of do integration and deployment from your internal local laptop development environment to any cloud you want to connect to and test it, right?
Right.
If that wasn't hard enough, you then have how do you orchestrate and manage all of these different components? So right now, developers, as they look at the different tool sets that are available for them for orchestrating, Mesos, Marathon, Kubernetes, Console, there's all kinds of solutions out there for orchestration. Bosch, right? If you're looking at Cloud Foundry, they all work within their specific use case. But if you want to go to a different use case or a different cloud provider, you have to then figure out what you need to leverage to connect to that cloud provider and leverage that orchestration layer, right? After you deploy it, then it's how do you assure it? How do you provide the service assurance piece? And that's something that is pretty much up to each developer to figure out how they're going to integrate and create, the events and manage those events from a service assurance standpoint. The other thing I didn't call out explicitly, but the whole testing of this, right? The number one thing we found with our microservices infrastructure work is that there is no end-to-end testing solution out there that tests all these different components and helps you build a test platform to kind of ensure that your code is valid and working well and there's no security vulnerabilities, right? And it doesn't integrate with the existing tool chain that enterprises have at all. And so you're kind of now the developers are also stuck trying to figure out how they're going to test their code. And then when there is an issue, right, there is, none of these tools connect into Remedy to kind of give you a good ticketing platform to manage issues and manage and log events that are happening against the system. And so that whole issues management aspect is very key and is missing. And something that developers have to kind of figure out how do they tie these different systems together and create a way to manage issues. Which then feeds you right back into that whole project management at the very beginning, and that whole tool chain, again, has to be kind of piecemeal together each time they do something to a different cloud. That's kind of a high-level view of the different pieces that I'm referring to,
So those factors are factors that Cisco faces, I expect, too, right?
Oh yeah, every company faces these issues today. I don't think there's any company that's not facing these issues. The other thing that's happening at the same time as this, right, is Cisco kind of saw the need in a slightly different way from the standpoint that a lot of our enterprise customers are looking to be able to deploy their workloads and manage their workloads from different geographies. And be able to connect across multiple different types of partners and cloud types, right? So this concept of intercloud was sort of born around how do you provide a single interface for an enterprise customer to manage their workload and the security and compliance and governance concerns that they have for their workloads across a world of clouds, right? So kind of like we did with the internet, we're trying to do the same thing with clouds because we feel like there's a very close analogy to what happened with the internet back in the 90s and what's happening with cloud today. And so this intercloud concept was sort of how do you kind of enable these applications and services to run in the public cloud, in the private cloud, in a Cisco OpenStack cloud that we call Cisco Intercloud Services, or in a Cisco Power Cloud, which today are mostly VMware clouds, right? VMware-based clouds. And so as I, came into Cisco and started thinking about that use case, to me, being able to write your application or develop your application and then be able to separate that development from the deployment scenario, but be able to enable that deployment to work across the intercloud meant that you could truly develop your app once, deploy it into whichever infrastructure you want or whatever infrastructure your company has selected you deploy into, including the public domain. And then you can run and manage that from that location on, right? So you can, this concept that I call hybrid DevOps of I build my application like I always do on my local laptop. I do a git push to push it out to the cloud environment. From there, I can then select my deployment environment, whether it's Amazon or Google or Cisco or a VMware-based cloud. I can push that code out to that location from my git push location, whether that's in the GitHub Enterprise account or whether it's in the public GitHub. Doesn't really matter to me, right? I can do it from either location, and then I can continuously integrate, continuously deploy using that shipped interface that we have, and that microservices infrastructure component will continue to keep those applications running and monitoring them. And I can manage that, and I can do service assurance and issue management all from this shipped interface that we've built. How do we make it so that applications can be built and deployed in the intercloud, and then make it a intercloud with the public-private hybrid model, right? How do we kind of do this hybrid DevOps model so that I could keep my database in my enterprise in my enterprise private location? I can put components of my application or leverage components of the public cloud and my Cisco cloud or my partner clouds and manage that application as a single instance deployed, even though it's deployed across multiple clouds.
Okay, so explain this concept of the hybrid DevOps a little bit more for me.
So hybrid DevOps is the ability to develop locally and then be able to deploy into either a enterprise data center or into a public cloud or into a Cisco powered cloud or into a Cisco cloud. So kind of this ability to develop your application on your laptop, deploy it into either your internal data center or an external data center or a public cloud or a partner cloud.
Okay. What you're talking about when you're leading off this conversation is looking at this from that business acceleration perspective and achieving business objectives, right? And
tackling
what you
the issues
described,
that the developers have to kind of tackle themselves today, trying to tackle those issues head on and make their life easier, while at the same time the infrastructure already has been getting easier, right? So it's just a deployment environment in my view, right? And so how do we tackle the developer issues? Because the deployment environments have already started to be tackled. There's things we can do there that make them better, as you already know, right? But if you just say that problem is already being tackled, the developer problems haven't really been tackled. We're focusing on tackling those developer problems.
And those developer problems, again, and I think, circling back to the concept of hybrid DevOps, those developer problems really reflect on these issues that have been present in the enterprise for years, and that's really the struggle with the cloud, right? And trying to, find ways, and I think we've seen it in kind of multiple kind of ways. We've seen it with like this wave of the private cloud, right? And we've seen it with Amazon Web Services and how do you connect with, these major cloud services. But it still came down to this core problem where you had, developers really needing to solve problems while IT was trying to solve larger infrastructure problems. And, and that is kind of encapsulated and kind of in like what you see with source code repositories, right? Trying to like push the pieces together so you can actually deploy, right? And that's and deploy. It's not just so simple just to think about deployment. It's actually an issue of like this intercloud, as you say, right? Is this hybrid DevOps concern, right?
It's really tackling that, SDLC flow that developers have been struggling to sort of address some of these issues, as you said, for a long time, right? The simplified view that you see on our website is develop, deploy, and run, right? And so that's sort of at a high level, taking the whole SDLC flow, which has multiple stages, and kind of breaking it into, that develop piece should be done in the way that developers normally work, right? We shouldn't be asking developers to change how they develop, right? Let them develop the way they always have developed. When they go to deploy it, that's where things like CI/CD come into play. That's where things like app orchestration come into play. That's where the different infrastructure components that may be targets for their application. That's where that comes into play, right? So let them develop the way they always have, help improve that deployment scenario, so they have an ability to really test that deployment in their development cycle versus having to wait to test till it goes to production. And then the run of that, which is give them the right visibility and the right issues management plugin so that they can actually run and operate that service from those cloud locations seamlessly.
You talked about kind of like this, the capability that microservices offer. What's been the impediment that has prevented from these microservices environments really emerging?
To me, with that background of sort of trying to tackle some of the harder developer problems, trying to tackle some of the make it easier for developers to be able to get their application up and running in an environment and be able to then kind of manage it from that point on with the CI/CD capability, right? Microservices sort of lends itself to a component of this, which is, again, trying to isolate and segment services and dependencies between services, kind of getting away from the monolithic code base to smaller, more composable application components, right? And so microservices is a good example of how you can accomplish some of these components by looking at how you write your application, how you would compose the application, how you would keep it as small as possible component, right? And not have to depend on some of the underlying infrastructure or operating system pieces. It doesn't, in my mind, solve the entire developer issue. It's sort of to me, it's similar to what VMware did to servers, right? You're able to virtualize servers, but as you know, every VM installment for the first 5 to 7 years was you took a physical server and you made it a VM. You didn't make it multiple VMs on a server, right? You just kept one physical server equals one VM. And it took years to kind of start trying to consolidate and make the change to have multiple VMs on a server and get the business to be okay with that. And I think containers has a similar model, right? It's saying instead of having a single VM, right, you can now take that VM application and break it up into 3 or 4 little microservices that are still running on that server, right? So it's sort of the next evolution, if you will, of the platform for virtualizing and isolating your software into smaller composable units, but it doesn't completely solve that overarching developer use case that Cisco is going after.
Okay.
But it does meet a very important use case of composing your application and thinking about how you can compose that application into a smaller set of services that can scale out independently, and you don't have to waste a lot of resources and a lot of bandwidth on these monolithic applications that have a hard time scaling out, right? So it does solve some pretty big problems.
Yeah, because now you can break it into those. Now you can break it into those components. You can start thinking about composable applications. So how did you guys embark upon that effort yourself?
So as we went down this path, right, there were a couple of things we looked at, right? And so as we're talking with a lot of our customers, the cloud native app developers are looking for, some specific capabilities around app orchestration and CI/CD. They're wanting to use more open source components, right? As we started talking to data scientists, they were looking for some similar components and similar capabilities, but they were more interested in kind of the Hadoop and Spark and some of the data streaming and data processing and data virtualization aspects, right, in addition to just what the cloud native guys were looking for. And as we talked with IT leadership, right, the IT guys were not really sure, how to really provide cloud native and all these data analytics tools. And, to them, they were very, overwhelmed because as usual, they're trying to just keep their legacy infrastructure and legacy services and their legacy support systems all working and running and supporting everything. So they're just like way behind in what is being asked for, right? And so as we looked at, well, what do we need to do to kind of meet the needs of our strategy, right? And so it was kind of a two-prong approach, right? So the first piece was we kind of need a user experience that helps kind of map to the developer use case and the developer scenario. So we spent a lot of time kind of thinking about what's the customer journey look like for a developer? How would a developer want to interact with these different options that are available to them today with microservices coming and with PaaS here today and with the way cloud native development is being done and some of the open source tools around that. So we kind of looked at what's that experience, and that's what we called shipped. And then we looked at the underlying framework to be able to enable that experience, and that's where the microservices infrastructure work came from. And the idea with the microservices infrastructure work, it sounds like really simple now, when I tell you what we did, but it was not very obvious to a lot of people. I think it's more obvious now that we've done it, but it probably wasn't so obvious at the time. But you sort of needed to have you needed to be able to provide the core frameworks and components. So we kind of started off with like Mesos and Console, and we need to be able to deploy to multiple data centers because the whole thing with InterCloud is multiple data centers, right? We know how important high availability is, so we wanted to be able to make sure that we had some high availability aspects, right? We picked Mesos primarily because of the framework approach that it has, and we started with Marathon. To meet some of the data analytics needs, we've added in Elasticsearch and HDFS and Spark and Storm and Kronos. We're doing something with React that we're announcing next week at MesosCon, and so you'll see that as well. We're adding Kubernetes in as well to the frameworks piece. We wanted to really focus a lot on security. We feel like one of the differentiators for what InterCloud is trying to do is the security piece, and so we've spent a lot of time, and we'll continue to spend a lot of time focusing on how to secure the underlying microservices infrastructure to the best of our ability, right? We know from that run standpoint, we need a lot of operational aspects, and to me, operations there's a big gap between what the infrastructure provides, what the different open source tool components and the frameworks I mentioned before, what they can provide you, and what the application owner cares about, right? If an application owner has to say, okay, let me log in to Mesos and see what it's telling me. Now I'm going to go log in HDFS and see what it's telling me. Now I'm going to go log into Spark and see what it's telling me. If you're asking a developer to have to go and basically put 5 different screens around his desktop so he can see all the different events and all the different issues happening around the different frameworks, then it's going to be very difficult for him to tell his customer what the problem is when there's a problem, or even know if there's a problem, much less tell his customer there's a problem, right? We're really focusing a lot on how do we provide the right level of logging and metrics, and how do we kind of roll this up into a single system view that shows all of these loosely coupled distributed systems at an application tier, so the application owner can understand how their application is performing. And then there are things we're going to do in the future to kind of enhance that experience with policies. The second thing, the third thing, so there's kind of the frameworks piece. There's the kind of general intercloud capabilities. And with that, the general intercloud capabilities I mentioned before, the thing that we've done that is sort of focusing on the microservices infrastructure piece is how you would connect to different cloud providers, right? And so we started with the easy ones like Google and Amazon and Cisco's cloud and our Meta Cloud, our private cloud offering. But we've expanded that and are expanding that to like Microsoft and VMware and DigitalOcean and CloudStack, just because they're easy to create these frameworks, right? And that's the other part of the microservices infrastructure piece is if we're keeping this open source and we're doing this to really help the developer, and so we want to keep it open source, then we need to make it very easy to be able to add in different types of adapter types or frameworks to support other non-Cisco intercloud locations, right? And so, Rackspace is, we support OpenStack by native support because OpenStack is different than the Cisco Cloud OpenStack. Probably there probably some few nuances that are different. Rackspaces, has their own kind of way of doing things, and so we have like what I call like sort of native, out of the box support for OpenStack that would probably get you 90 or 95% of the way there with any OpenStack distribution, but there may be a few things you need to change or enhance, and that code is open, and so we're trying to keep it all open. Those are the areas that we sort of looked at from a microservices standpoint, right, from a kind of requirements, right? And then we kind of thought about it in terms of control nodes and resource nodes and how to kind of look at a distributed systems deployment, right? And so, we did things from a central node standpoint that kind of put some of the Mesos leader, for instance, and like the collect D for collecting the logs, some of the DNS stuff that we're trying to do for providing IP addresses to the containers, some of the Docker components that are needed to kind of manage and run containers. We put all that into the control node, and then the resource nodes, we try to kind of keep them very light. We try to keep, a couple of agents in them, a couple of, app and HA proxy components that are available from the Docker side of things, right? So you can kind of leverage the Docker ecosystem pretty easily there. And really the key was just tying these things all together in a way that allows the developer, again, to just kind of focus on writing that application code and not having to focus on how do I configure Marathon, how do I configure, console, how do I configure, collect D. Everything sort of gets pre-configured. We have a namespace that we created that developers can kind of create names for the different services, and it would actually show up as that service name in the namespace. So simple little things like that, the development team is really trying to make it super easy. Again, going back to that user experience to make it very easy to run, deploy, and build services without having to understand the underlying pieces with a lot of detail.
So tell me then about the features, for example, that you implemented. I mean, it's laid out pretty well on GitHub. You talked about the control nodes and the resource nodes. Tell us some of the features and the decisions to use the features that you did.
We didn't do an official crowdsourcing, but we kind of took a crowdsourcing approach to try to understand what are the types of tools that most of the developers are sort of leveraging today as they're doing their developments into private clouds and into public clouds. And so we kind of there were a lot of options, as you know, and we looked at as we looked through this, and there's a lot of religion, I guess I would call it, around some of the different tools available. And so we took a framework approach because I felt then, and I still feel today, that there are going to be certain components that a developer is going to, either because they have always developed it that way, or because the company has said this is how you need to leverage, this is what you need to leverage for this part of your SDLC flow, or because they've said we're going to go down a Cloud Foundry path and we want you guys to convert everything to Cloud Foundry, right? Whatever the reasons are, there's always going to be a need to support a different capability. And the other point that I think is important here, Alex, that I've been thinking a whole lot about is there's this, for as long as I can remember, there's always been a next generation something, right? I was working on a next generation network 25 years ago, and every couple of years there's another next generation network to come out, right? And so there's always a next generation something. And what I told the development team is I don't want to have to create, different versions of microservices infrastructure and shipped to address some new cool capability that's being released by vendor X or by open source project Y, right? And so the idea here is that, being a hybrid DevOps model means that as new capabilities come out, they become just another framework that we add to the microservices infrastructure. And at that point, the developer can either leverage that new capability or not. And a good example here is we've tied into Cisco's DevNet environment, developer.cisco.com, and inside our framework, we've added the APIs that DevNet has exposed for Cisco products. So if you're like a partner of Cisco and you wanted to develop an application that take advantage of our CMX, our wireless access point APIs, we have integrated those APIs with our platforms. You can actually do your development and get all the APIs downloaded to your development environment by just selecting the CMX APIs in our shipped interface. And we did the same thing with the APIC EM APIs. And so, the advantage of this is that as you add capabilities, or as you want to add capabilities to your development cycle, they're just a plugin or a framework that you add in. You don't have to redesign or redevelop the whole experience just to add a new capability. There was some piece, like you said, to go back to answer your question specifically, we kind of crowdsourced the initial features, and so we picked HashiCorp because they have a lot of interesting components that really fit our direction and what we've been thinking about. So we picked Terraform and Console, Vault from managing secret standpoint. We've also looked around, and a lot of people were using Mesos and Marathon for their container environment, and so we selected those components, and we liked the framework aspect of Mesos. So we started working closely with Mesosphere and some of those things, right? And so we kind of started there, and we knew that the data analytics platform is important and will be very important in the future for the use cases that we're targeting. And so we spent, we kind of looked at the same thing with sort of the crowdsourcing approach, looking at what were the data scientists trying to do, what were they looking at as tools that they needed in the frameworks. And so that's what kind of Spark and Elasticsearch and some of those areas, some of those aspects of the data platform came into play for us. But we did select these components, and we do have it all working today end to end. And so that's kind of our first release, or the alpha release we called it. And we are productizing that for a GA release in October. But the key is we know that there are other components, and we use Get, for instance, for like our project management and issues management. And so it was easy for us to kind of do this because we're leveraging public tools and public capabilities. For some enterprises that don't have the ability to use a public GitHub account, right? We need to add things like enterprise GitHub account and Raleigh and Jira and other development frameworks that are being used in the enterprise. So we're definitely working on those frameworks. We also have customers who are telling us they want Cloud Foundry or they want OpenShift, and so we're looking at how do we leverage from a CI/CD and an app orchestration standpoint, how do we kind of bring in Cloud Foundry and OpenShift components into this framework as well, without having to redirect them to some other interface.
So tell me how you're crowdsourcing, and what you guys view is on kind of integrating with other orchestration environments like Kubernetes.
Yeah, so Kubernetes is something we're adding in actively right now because we see the value from its scheduling standpoint and a few other aspects that we like about it. And so Kubernetes was one of the high things on our list, so Kubernetes is definitely going to be there. The other components that we see a lot are, like I mentioned before, enterprise GitHub and Jira are the two kind of internal components we hear a lot about. We haven't talked much about like Remedy and Service Desk and things like that yet, but I've been trying to get some discussions with our enterprise customers to see, is that when it comes to integrating to internal IT systems, I'm not sure if that is a framework that we would create and make it really easy for the enterprise to plug into, or if we would kind of just publish the framework and say, here's how you plug in your tool that you use for ITSM into the framework, right? And so I'm kind of thinking of taking sort of an approach of we will maybe write 3 or 4 frameworks on the most popular ones, and then publish a framework for the ones that we don't want to write for, Or we could even charge a customer to write for that if we wanted to, I guess,
So where are things right now? I mean, you made these decisions on the features. You have this architecture, control nodes, resource nodes. People, I'm sure there's lots of people getting started. I mean, the GitHub repository is reflective of that. Lots of stars, lots of forks.
So today we're on release 0.3. 0.4 is due to come out next week at MezosCon. We're looking at renaming the project from Microservices Infrastructure to Mantle, M-A-N-T-L. And what you will see next week is, you'll see Kubernetes, you'll see Kafka, you'll see Elasticsearch, and all the data platform stuff like HDFS, Spark, Storm, Kronos. And you'll see a few more cloud providers added as well in the release next week. So we're going to be moving to 0.4. Our plan is to keep this whole project open source. We don't plan on doing anything in this project that is not community related and based. We have lots of requests from the community. What's sort of the big next steps for me for this environment? If you're kind of wondering what's the next big things, right? So there's some network enhancements that we've been working on with a couple of interesting partners that we have in this space, as well as internal Cisco teams that have been doing some interesting work in container networking space. And so there's a couple of big things they were working on for a little bit later this year. Application policy intent is something I plan to demonstrate at Congress and OpenStack Summit in Tokyo. And so I have, in the same way that I feel like the developers have been, we haven't really solved the developer problems yet in the industry. I feel like from a policy standpoint, we're asking developers to tell us how much CPU, how much RAM, how much bandwidth they need, what ACLs they need, what ports they need opened. To me, it's just like 1980s, right? I mean, the network.
They don't know.
They don't know, and it depends. Like every time you ask them, it's going to depend on many things, right? And so, my view is what I call application intent, which is let's define high-level business objectives, super high-level, right? Find out what's important, what are the things that they need defined from an objective standpoint around sensitivities, right? Not around specific numbers or specific parameters. And then let's use our infrastructure intelligence to figure out when to spin up more CPU or when to spin up more disk or when to move an application because availability has decreased on it. Let's open up the ports that are needed based on what ports get open on the application. Let's not ask them to tell us what ports to open, but let's look at the application, open the ports that it's asked for. And as long as it's not a well-known security port that's being opened as a vulnerability, right, then we know to open it, right? As you look at, the need for applications to perform at much higher rates, that's another thing with this competitive nature, right? My view is very much around and you could say it's sort of lock-in. I'm not trying to do vendor lock-in. I'm just basically trying to make the application so well performant on a Cisco infrastructure that they're not going to want to run their application somewhere else, right? They still have the option to. I'm not going to force them into a Cisco infrastructure, but if they want their application to perform at its most optimal for their customers, they're going to want to be on our infrastructure because we've optimized it for their application. Self-tunes and self-optimizes from that point on, right? They don't have to go back and worry about it ever again. So those are kind of the two big things. And then the third big thing is a little bit more on monitoring, right? I think the gap between APM tools and infrastructure tools is just so large that I feel like there's some innovative things that we can do in that space, and like especially, right? Like especially when you look at the view between what an application is trying to accomplish and what the underlying infrastructure can tell you about that application, right? It's just there's a huge opportunity there to do some interesting things that we're focused on as some of the one of the big releases coming up in this early this quarter or next quarter.
So what are some of those gaps that are really glaring in monitoring?
Probably the top 2 or 3 gaps that I hear and talk with customers a lot about are the degradation of performance is not easy to detect at the application level or at the infrastructure level. Many times a customer will call in and complain about slowness or the application isn't responding as quickly as it should or they'd like to, right? And you go and look at, New Relic or look at some of the APM logs and everything looks great. So it must be an infrastructure problem. So you call the infrastructure team and they look at, first of all, they don't understand exactly what the application is, right? Where all of the components for that application reside. And so they kind of have to work and try to look at different pieces of the infrastructure. They have to try to map that application components to the different servers that they're running on. There's not really anything out there that does a great job of kind of mapping the application and all of its services and components to a single, set of infrastructure aspects that can then be looked at and understand if there's like a delay or if there's a routing issue, or if there's a problem in the storage environment, right? And so that's sort of the top thing, is just making it very easy to, as we register services, we want to register the location of those services and the underlying infrastructure components that those services are residing on, so that when the application developer looks at the dashboard, they'll see something turn red or yellow, and they'll be able to go all the way down into the infrastructure, if that's where the problem is, to see what the problem is or where the problem resides. They don't have to try to guess where the problem resides. So it's not going to be process by process like a New Relic is. It's not going to be as detailed as an application performance monitoring tool, but it's going to give you a better tie from the application to the underlying infrastructure. So it's going to be kind of looking at what sort of the bare minimal set of capabilities that the application would want to know about the underlying infrastructure. If there is a problem or an issue within the application itself, the customer would probably still need to leverage the New Relic or App Dynamic type of software solution to really understand what the application issue is, right? But most of the issues I see in applications are not at the application level, and they're not an obvious infrastructure issue, right? There's always a different model or a difficult problem to find because it's intermittent sometimes. It's dependent on location sometimes, and it's dependent on the load on the load balancer. It might be dependent on the server utilization at that moment, right? So there's all kinds of things that it could be, right? I had a problem one time where VMware, for whatever reason, vMotion loves to move the busiest VM, and so whenever this peak load would hit this customer's app, their VMs would start to vMotion and they would have issues. And when we go look at it, everything looked fine. And then we look at the logs and say, oh wait, this VM vMotioned. And then we started, tying over a period of days. We started tying together. Oh, when they have a peak load during this time, these VMs vMotion, and that's when they're seeing this issue. And it, if it wasn't for being really, really, really on top of what these different issues could be, that's a problem that many companies never probably figure out, because who would think of looking at the VM vMotion logs, right?
Yeah. This speaks to a lot of the innovation that's still needed in the data center itself, doesn't it? For example, with better understanding that almost environmental issues between the infrastructure itself and the resources that are running on the infrastructure.
Yeah, and that's why I kind of started there, Alex, because if you look at the data center space for the last 15, 20 years, right, there are some major components and visibility and awareness things that were just never accomplished, right? They moved from bare metal to virtualization to private cloud to public cloud, and yet they didn't really solve some of the major issues that they've had in the infrastructure or in the OSS systems or in the the example I always give, if it makes it easier, Alex, is VM sprawl, right? There's always been this problem of server sprawl forever in the enterprise, right? When they moved to virtualization, all of a sudden you start getting VM sprawl, right? They never solved the core problem that caused server sprawl, and VMs made it even easier to spin up servers. So why not spin up more of them, right? So you basically compound the problem because it's easier, and then you move to cloud. And cloud, I always told Sam, is like crack, right? Once people start using the cloud and see how fast it is to get their resources up, they just want more and more VMs in the cloud. They just want more and more cloud servers, right? And more cloud storage. It's like crack to these guys, and it's a good thing because, people wanted to provision a lot of it, but you still haven't solved the problem, which is not having excess use of capacity, right? You now have more excess use of capacity than ever before because you never addressed the root problem of excess capacity.
Which was always a problem in the VM world, right?
Right. And it was always a problem before the VM world, right? With bare metal, there was still a problem, right? So it's, almost all the problems I'm trying to solve are problems that are not new problems. They're new in cloud, but they can be traced back to not having solved them ever before. So, I could try to say they're all new problems, but in my mind, there's probably a few new problems, but in general, they're all legacy problems. But when you look at, I think what is new and what I'm trying to do is the combination of private cloud plus public cloud plus hybrid cloud. I think those areas, that's what's kind of new here, right? Because the problem becomes compounded when you have internal infrastructure you're connecting and supporting. Every enterprise has to manage their application using their internal systems. They have security and compliance controls they have to have in place around their application, right? And so you have all of these internal data center controls that you need to be able to understand how to manage. And then when you move to a cloud provider of any type, cloud providers have their own set of support systems and billing systems, and they do things a little bit differently than what any enterprise does. And so now you have to sort of manage your end systems plus the cloud provider systems. And then when you move to kind of multi-cloud or public cloud, the same, that problem just becomes more compounded because now you have multiple systems you have to talk to, multiple ticketing components to work with. And so trying to figure out how to solve the Uber problem is sort of new, but they're just extensions of the problems that were never solved in the first place. You could say APIs are kind of new. You could say that having a bus or service, the enterprise service bus is now kind of extending to the cloud. That's sort of a new problem. But
who was the well-known personality who said when asked how do you make apple pie from scratch, I said, well, let me start with the creation of the universe. Is there anything else you'd like to add to what we've discussed here? You haven't really touched on like what this means for Cisco.
So there's a couple of tie-ins. The first tie-in is on the intercloud piece, right? So being able to develop your app and deploy it into the intercloud, which is again, public cloud, private cloud, Cisco's clouds, and Cisco-powered clouds. That's the first piece of tie-in, right? This architecture and this strategy is meant to really address a hybrid cloud, multi-cloud world. The second piece is I really think microservices is sort of the right architecture for fog computing or edge computing. That's part of the whole IoT initiative, right? And so the second tie-in here for Cisco is, how do we take advantage of microservices approaches to enable all of these billions of devices that are going to be connecting to billions of sensors that are going to be connecting billions of servers to our cloud and collecting all that data, managing and resourcing all that data, analyzing all that data, and providing business intelligence back to the customers what they want to do with that data, right? Fanuc's a good example here where they do a lot of robotics in the manufacturing of vehicles, and we've been able to save them a lot of money with our intercloud because they can get data out of their robots on the floor of the manufacturing plants and determine if they need to send a technician out or send out a part and have someone else on site fix that part, or if they just need to connect to the robot and do some diagnostics and reboot it. We have a really good use case with Fanuc, one of our big partners in IoT there, that we could talk about at another time if you want to. The third piece that's part of the Cisco strategy is it depends on who you would talk to at Cisco, but most everyone at Cisco agrees that the buyer of services for the enterprise is changing to the line of business owner or the developer. And so, this is it. Everyone pretty much agrees. I think everyone disagrees on the timing of that, whether that's going to be in the next 2 years, 3 years, 5 years, 10 years, right? But the view is that it's going to happen, and we want to help be part of that next. We don't want to be disrupted. We want to be a disruptor, right? And so a part of this is part of Cisco's disruption strategy to ensure that we have the right capabilities to really help disrupt the market when it comes to doing the next generation of services and platforms that the enterprise is looking to deploy or offer or leverage as a service or buy from a vendor like Cisco.
That brings things full circle to the top of our conversation.
Exactly.
On that aspect of disruption. So, well, good. But we didn't even get to unikernel, so we'll have to talk about the next generation stuff another time. Thanks a lot for taking the time.
Thanks. Appreciate the time, and look forward to continuing these discussions as other pieces and other components of the book come out.
Great. All right, Ken. We'll talk
Thanks,
soon.
guys. Yeah, talk to you soon. Take care.